Welcome to HTML5 webinar series from JPassion.com. Today's topic is Canvas, HTML5 Canvas, topic number 3. So let's start with the presentation. So these are the set of topics that we are going to cover. We'll talk about what Canvas is, and then basically we are going to see how you can actually draw shapes and add colors, transparencies, gradients, transformation, compositing, and also you can do some basic animation. And at the end, we'll see how third-party Canvas libraries can actually help you to build really nice graphic-based application. We are going to cover Canvas versus SVG. Next week, we are going to learn SVG. And one of the questions people ask is, what is the advantages of using Canvas versus SVG? And in fact, when should I use both? So we'll cover that as part of the SVG presentation next week, once we cover SVG as well. Some of these contents are from Mozilla Development Network. So what is Canvas? You can think of a canvas as a drawing platform for 2D graphics. And then you are going to use just HTML and JavaScript to draw the graphics. And you don't need any extra plugins. This canvas drawing platform on the browser is represented by a canvas element. So this is a new element added in HTML5, and this element represents this platform. And then you are going to use JavaScript to add graphics. So as I said, Canvas is an HTML element which can be used to draw graphics using JavaScript. Okay. And so this is typically what you see in Canvas, in HTML page. It's a Canvas element, and you can specify an ID just like any other DOM element, and then you can specify width and height. Okay, and then later on you are going to use JavaScript to add graphics to this Canvas element. So you can think of Canvas as a container for graphics. But you have to do JavaScripting to add those graphics to this canvas. So canvas is a blank screen, so to speak. Okay. So canvas creates a fixed size drawing surface that exposes one or more rendering contexts, which can be used to create and manipulate the context shown. So far there is only 2D context. There are two contexts you can use. One is the 2D context, and the other one is a 3D context. We are going to focus mostly on 2D context. So as I said, canvas as a drawing surface is initially blank. Initially blank kind of with a fixed size, and then you're going to use a JavaScript to add the graphics. And basically, in order to draw graphics on the top of canvas, you have to get a rendering context. So this rendering context is again 2D context and 3D context. The reason you need to get the context first to draw, so you are going to draw the context rather than canvas directly, is because canvas might sometime provide a different context, again 3D context. So it actually provides intermediate layer like a context to which you're going to do 2D graphics drawing. Okay. All right, so canvas element has a DOM element called the get context. That's the one that you're going to use. You're going to obtain the rendering context. So you're going to call. So here you're going to. So this is the code. You're going to get a reference to your canvas element by using get element by ID, and this is the ID. Okay. So in the previous case, this is the my canvas, and then from that object, you're going to call get context, and you specify I want to get 2D context. So once you get the context object, then you're going to draw with that context object. Okay, so we'll see example of that in a few seconds. Okay, graceful fallback for old browsers. So old browsers which do not support HTML5, in this case Canvas, you want to provide a fallback content. Okay, so the things inside between opening and ending tag of canvas element is considered as a fallback content. So in this case, when the canvas is not supported in an old browser, basically you are displaying this image. Okay, or you can have some kind of text, your browser doesn't support canvas or something like that, or you can also use a scripting language to check whether that particular browser environment supports a canvas or not by using canvas.context. So you're basically checking whether there is a getContext property, okay, which references the the function object of this. So that's the reason you should be able to call like this. So you can check whether canvas well, this should be actually my canvas or whatever name of ID of that the canvas element, and then you can check whether getContext property is there or not. If it is not there, then that means it's the old browser, and if it is there, then you can actually get the context object, and then you can start drawing on the context object. Okay, so let's see how you can draw shapes. Drawing shapes in Canvas, just unlike SVG, SVG later on next we're gonna learn SVG. SVG supports multiple shapes like a rectangle, triangle, and things like that. However, in Canvas, it supports only a single shape natively, which is a rectangle. Everything else has to be constructed using path. So that's what you're going to learn in the following slide. Okay. So all other shapes, triangle or whatever, must be created by combining one or more paths. Okay. So we are going to see all these paths later on. Canvas provides a collection of path drawing functions which you can create any shape of your choice. Okay, but the native the shape is that is supported by Canvas is rectangle only. Okay, so Canvas provides several functions for drawing rectangles. One is fill rectangle, so it basically draws a filled rectangle. So this is the starting coordinate x and y, and width and height of that rectangle, and it's gonna fill it. Okay. Stroke is draw a rectangle outline, so it doesn't fill, but it will just have an outline. And clear rect is going to clear specific rectangle area and makes it fully transparent. Okay. So let's see this code. So you are going to get the canvas element, and then you're going to call getContext object, getContext method, and you got the context object. And then you are going to call these methods. Fill rect, in this case, I'm actually starting 25, 25. So this point, this is the coordinates of 25 pixels and 25 pixels. And the size of this rectangle is 100 width and 100 height. So this black one is represented by this code. Clear rect is clear that rectangle space. So that is in the middle. So this white square, okay, is actually from this. Okay, so the point here is 45, 45, and the width and the height is 60, 60, and this is the last one is a stroke rect. So it doesn't fill inside, but it's just the drawing the outline. Okay, so pretty straightforward. All right, now as I said before, except rectangle as a native shape, everything else has to be drawn using path. Okay, so path is a line. Okay, so internally, you are going to have a collection of this path. Okay, so it's in fact they are saved as a list of paths, and they will actually construct a shape. So the way that you are going to draw other shape, the other than the rectangle is, you're going to start with a begin path. So whenever you call this begin path method, basically it's going to create an array of subpaths. So that array is going to be empty in the beginning, right? Okay, and then you are going to call move to. Move to is basically you move to that location first. Okay, and then you are going to call set of line to. Line to is you are actually having pen sort of from the move to location to that line to location. Okay, so move to is like you are moving your pen without actually drawing anything, but line 2, you are actually moving your pen from the location, from one location to another location. So you're basically constructing a line. Okay, so you're adding that line. There is also a closed path. Closed path is that, if you call closed path, the last point and the first point will be closed. Okay. However, if you draw a shape that is already closed, then closed path does nothing. Okay. And then, so up to this point, what you do is you are basically creating a collection of paths, meaning collection of lines. But they are not really being drawn. They are just collecting the lines that will be drawn later on. So in order to actually draw it, you're going to use stroke method or fill method. So stroke method will actually draw the lines, and the fill method will actually paint the solid shape. It will fill it. Okay. So until you call stroke or fill method, things are not actually going to be drawn. Okay. So these begin path and move to and set of line to method is basically constructing an array. Okay. All right. So let's next is a drawing text. So basically you can set the font, and then you're going to use a fill text, and you can specify the string, the text, and then you can specify the location, starting location, and then you can so fill text is this case, the first. Okay. Stroke text is that basically you are going to have a stroke based text like next one. Okay. All right, so let's do our first lab. So we have 10 exercises. The first one is drawing shape. Okay, so basically this is the one that I showed to you. Okay, so by using your browser of choice, you can go to this location. So I have that. So the hands-on lab contains a samples underscore HTML5. And this is the code. Okay, and here you can open a browser like this. Okay, or you can go to just the link. I provide the link, so you can just go over there like this. Okay, so if you take a look at the code, I'm gonna actually use the lab documentation to show you what's happening. So this is the same code that you have seen in the slide. So here we get the canvas object. Okay, and then we check whether this browser supports canvas or not, and then we get the context object here, and then we draw 3 rectangles. Okay, for your exercise, you can actually try different. For example, if I try. I'll just yeah, okay. You can have another one, maybe 45, and then save it. Yeah, so another one. Okay. So, basically you can try these things yourself, okay, by changing values. Our next one is drawing a line. So I'm going to just go here and you draw the line, okay? And let's take a look at the code. So, except the rectangle, as I said before, whatever other shape, whether that's a line or whether that is a triangle, you have to construct a collection, or array of path. So here we are drawing a single line. So we move to the 0, 0 location, and then we are creating a line 2. So we have a single line, and then if I want to draw that line, I'm going to call stroke method. So until the stroke is called, it will not be drawn. Okay, so let me actually go over here, and so this, if I actually, if I have it like this, right? By the way, I'm going to actually use what is called a live page, and whenever I make a change and save it, it will actually get reflected right away. So I'm going to just, remove this stroke line, and then if I save it, and you can see it's not being drawn anymore. Okay, so that actually verifies that stroke is a method that actually, draw things. Okay, all right. The next one is drawing triangle. So here again you have to create an array of paths. Okay, so we have actually two triangles. One is filled and the other one is actually just outline. Okay, so here we are creating a filled triangle. So we start with a begin path. Okay, and the starting point is 25, 25. And then we move to this point, 105.25, and then we move to 25 to 105, and then we call fill. So, it will actually create this. And then the next one is we actually do pretty much the same thing. And we actually even call the close path. And then we call stroke. So this is going to actually just call basically this. Okay. All right. So that is triangle. Text. So here, if I call this one, so here, we have two text. Okay, one is filled and the other one is the stroke style. So let's see the code. So we specify the font and then we fill the text, and the other one is the stroke text. Okay, so here, this is the filled text and this is a stroke text. So that's what you see here. All right, so let's move on to the next, images. So importing image is basically a two-step process. First, we need a reference to JavaScript image object or other canvas elements as a source. And it's not possible to use the image by simply providing URL path to them. Okay. Secondly, you have to create an image, the draw image using draw image function. In terms of the source of image, you can have image element, and then you can actually use this DOM APIs. Now, if you're using image from other domains, and then you can also use what is called the cross-origin attribute. It lets you actually access that image using the CORS, cross-origin resource sharing scheme, so that you are not going to be constrained by single origin policy. Okay. You can also actually use another canvas element, and also you can create the new image object from in your script. So let's take a look at the code. All right, so here we are going to see example of draw image. So here, this is the image, and then basically this is the location, starting location, origin location, and then width and height. Okay. So here we create the brand new image object, and then we specify the location of the image. And here basically we draw image, and here we're just in the loop. So basically we are creating 12 of those. Okay. You can slice the image. Okay. So basically this is the source and this is the destination. Okay. So this is the source and this is the destination. All right, so let's do exercise 2. So this is a case that we are drawing image. Okay, oops. Looks like my link is not correct. So I'm going to just go over here. And I'm going to just run it. Okay, so this is what you're going to see. All right, so here, let's take a look at the code. So here, basically, we have image element, okay, that specify the local image. So I don't have a problem with single origin policy because it's actually the same origin. And then I'm going to just call draw image, and then basically getting that the image object like this. Okay, pretty straightforward. And we are starting from 0, 0. And the next one is we are basically now drawing an image, which is basically providing this graph background, and then I'm gonna use the path, okay, to draw this this line. Okay, so if I click this one, this is what you see, and let's take a look at the code. So again, we actually have created image object, and we are providing the location of this image source, and then we draw image, okay, as we did, and then we draw lines on the top of it. Okay. Scaling image. So basically, we have this in this image, we are going to just scale it, okay, and smaller scale, and then we're going to display like a 12 times like this. So this is what you're going to see. Okay. So if you take a look at the code, you're basically, the drawing that image object, the same drawing image object, and then this is the scaled version. Okay, so XY, basically the location. The first one is the location, and this is the size of the scaled image. So you can slice the image. So here, if I click this one, the image is sliced. So we're actually capturing only this portion instead of the whole thing. Okay. So here, basically, this is the this is the sliced, the original and the destination. Okay. Okay, so that is image. Let's move on to the next. Colors. Colors could be either stroke style or fill style. Again, fill style is filling that shape, internal shape of the inside of the shape with a color, and stroke is just kind of outline. Okay, and stroke color representation could be a string representing CSS color value like this. Okay, or gradient object, or so this is actually these are all examples of CSS style. Orange or this value or RPG, RGB or RGBA. Okay, so these are all supported from CSS. Okay, or it could be gradient object, or it could be a pattern object. Okay, so this is typically what you see in the code using CSS color values. All right, so let's do color. So here we're going to try stroke style and fill style. So this one is stroke style. So here we are basically seeing the color of the circle. Okay. And we are basically using different values for RBG. Okay, so if you take a look at the code, you're basically computing the values of RBG. Okay, here and here. Okay, how we actually compute this one is not really important. Basically, we are just using RBG notation to set stroke style. Okay, so stroke style is just the outline. This one is fill style. So if I click this one, this is what you see. And fill style is basically calling, it's basically saying using the same color, but you're going to use the fill style property of the context object. Okay. All right, let's move on to the next. Transparency. So transparency, you have two different options. One is setting global alpha property of the context object. Or you can assign semi-transparent color. So you can create a color that looks like a transparent, okay? And then you can assign to, the stroke style or fill style like this. So either one is fine, okay? So let's try transparency. So here, if I click this one, this is what, oops, yeah, again, I think the link is not right. So I'm going to try transparency. Here we go, okay. So if I run this one, so this is what you see. And if you take a look at the code here, I'm actually setting the transparency global alpha 02. Okay, so this is what you see. Okay, and then I'm just applying to all the rectangles. Okay, so if I change this value to, let's see, maybe 8 or something like that. Let me just. Okay, again, I'm going to use a live page. So I'm going to change to 08, save the change. Okay, so transparency is really changed. Okay, so how about this? Oh, okay, here we go. So it looks like it's actually changing transparency on the circles. All right, moving forward. You can assign semi-transparent color. So this is a case that we are creating, semi-transparent color and then assign the fill value. Okay, so let's try to run this guy. If I run this one, okay, so this is what you see. And now let's try to change the values. How about I have to use live. Okay. How about this? Okay, it changes. All right. So that is transparency. Now let's move on to line styles. So you can actually have 4 different context properties for setting line styles. You can specify line width and line cap, so how the endpoint look like, and line join and mirror limit. Okay, so it determines how far the outside connection point can be placed from the inside connection point. All right, so let's do exercise 5. So this is the case that you are going to see a different line width. Okay. So here, depending on what line fit, width you specify, it will have a different line width. This is the line caps. You can see it has a different line caps here. Okay, so different types of line caps, and here we have butt, round, and square. Okay, and then you're basically specifying a different value. Okay, line join is this. So if you click this one, okay. And so basically you provide how the lines are going to be joined. I don't expect you to remember every API here. The goal of this presentation is basically let you know what can be possible. And in fact, I'm not actually showing all the possible features of the canvas. Okay, but as long as you got some idea in terms of what's possible, later on you can certainly actually find out the APIs. All right, so that is a line style. So let's move on to the next. Gradients. Okay. So gradients, you have a linear or a radial. Okay. So basically what you do is that you are going to create the gradient object, linear or radial, and then you're going to actually add color stubs. So color stubs is basically, how many, in fact, the points you want to actually apply these gradients. Okay. So if you have actually 2 stubs, then you will have 2 points where the gradients will actually change. If you have a 3, then you will have a 3. Okay. So here we are. This is the how you can create the linear gradient. Okay. So here starting point and end point of the linear gradient, and this is creating radial gradient. Okay. So the first the first 3 arguments define a circle with coordinates x and y with the radius 1. Okay, and then second circle with the coordinates of x and y and radius 2. Okay, and then you are going to add color stubs. Okay, so the color position, color stubs has to be between 0, 1 and 1, 0. Okay, you can have in fact as many as you want. Okay, and it specifies a relative position of the color in the gradient. Okay, so basically this position is the value between 0 and 1. Okay, and this is the color you specify. So this is an example where we are creating linear gradient object, and then we have just the 2 stubs. So it will have just the it will have the white one end and the black one end. Okay, so if you have another line, 0.5, like a green, then it start with the white, and then it will start with it will go to the green, and then from the green it goes to black. All right, so let's do exercise 6, which is gradient and shadow. So this one is basically providing gradients. So you can see this blue color is gradient, okay, and this is the green color is also gradient, okay. All right, so if you take a look at the code, here we created 2 gradients. One is the this, and the other one is for this. Okay. For first linear gradient, we actually have the multiple stubs. 0, 0.5, and so in fact we have 0.5 point. We have in fact have 2, so that will be combined. Okay. The next one we have only 2 stubs. Okay. All right. And then you're going to you're going to actually have this gradient object into the fill style. Okay, I say actually one is a fill style and the other one is the stroke style. This one is radial. So here you can see the gradients are actually radial within the circle. So it's starting from here, right? And he's starting from here. Okay, so if I click this one, this is what you see. And here we created the 4 radial gradient because we have 4 circles. Okay, and here we create a radial gradient, and then we add stops. So here we have 3 stops. Here we have 3 stops. Everything has, every circle has 3 stops. But depending on the value where that gradiency will start will be different. Okay. The shadow. So here I want to have a shadow on this text. Okay, so this is what you're going to see. And here, I can specify the shadow of X and Y and blur and the color. Okay, so depending on, so let's actually see what values have an impact. So let's try the shadow. Okay, so I'm gonna live. Okay, so if I change this X to 20, okay, then it goes all the way to the end, and shadow Y, let's say 40. Then it goes all the way back, all the way down. Okay, so you can see the shadow offset XY is actually pointing how far it actually goes. The shadow. Okay, the blur is actually the intensity of the blurriness. So if I say 6, it will be a lot blurrer than the previous case. Okay, all right, and of course color in this case is green. All right, so let's move on to the next transformation. Transformation is basically, translate and rotate and scale. Okay. Now, before we move on to transformation, one thing that you can actually take advantage of in Canvas is saving and restoring state. Okay. So drawing state is basically a snapshot of all the styles and transformation that have been applied. Okay, so the state includes a translated state, rotated state, and scaled state. Okay, the values of stroke style, so every other style information also actually being captured, okay, into a state. Okay, and also clipping state. So you can call the save method to save the current state, and then you can call restore to restore the state. Okay. You can actually call this save and restore as many times you want. Okay, so this could be used in fact actually for basic animation later on. Okay, all right. When saving and restoring state, so it's a good idea to save the canvas state before doing any transformation. So yeah, so suppose if you want to actually do some transformation and then get back to original state, instead of actually using the transformation to get back to original state, basically you can save and restore, and that's a lot easier. That's basically the idea of saving and restore. So if you perform like a 10 transformation, and then if you want to actually go back to previous state, you can certainly perform extra 10 transformation to reverse whatever things you have done. But instead of performing 10 extra transformation to get back to original state, you can just save and restore. Okay. So if you're translating inside the loop and don't have and restore canvas state, you might end up missing part of the drawing because it's drawn outside. Yeah, okay, I think I'm gonna just skip this one for now. All right, so there are 4 different types of transformation, and we're gonna actually mostly focus on translating, rotating, and scaling. So transformation in this case is actually providing some kind of matrix to have a really fancy, transformation. Okay, mostly you're gonna actually focus on translating, rotating, and scaling. Translating is actually move the canvas to the location, to a different location in the grid. Okay. By the way, all this transformation gets applied, okay, after translate function is called. So any shapes or anything that have been done that are drawn before translate function will not be affected. Okay. So remember that. So the way that you're going to actually perform translate is X and Y. So this is the amount of X amount of Y that will be applied for any the shapes that are drawn after this. Okay, rotating is rotating. Okay, so it's used to rotate the canvas around the current origin, and the rotation center point is always the canvas origin. So, it's important to actually figure out what is the rotating center. So in order to change that center point, we need to move the canvas by using translate method. So typically, we are going to use a translate method and rotate method together to set the rotating center. Okay. If you don't call the translate method, then the center of the rotation is always the canvas origin, which might not be what you want. Okay. Scaling is again scaling. Okay. All right, so let's do transformation. So this one is a translate. So this is the original box, and then this is the same box with a different color, but after translate. Okay, so let's take a look at the code. So this is the green rectangle that we've drawn here. Okay, and then we perform the translate. So we move the canvas 50 and 25, 50 to the right and 25, to the downside. Okay, and then when we draw a rectangle, that should be drawn, from the location. Okay. Rotating. So here, basically, what we have to do is to call translate. So let's actually run this one. So you can see the rotating point is here. Okay. So if I take a look at the code, let's actually take a look at this code. Is 7b. Okay. So this is what we see. Okay. Now, if I do not actually set the translate, so here we move the rotation point to here so that the rotation happens over here. Okay. But if I remove this translate, then you can see it's actually being rotated. The center is actually the origin. Okay. Okay, so that is rotate. So, so here is 45, and you can certainly change this value to, whatever value you want. That's an angle. Scale. So here we are scaling with twice the size. So here, this is the scale size. So here, again, we scale twice of the width and twice of the the length. Okay. So let's try that one. Scale. So this is what we see. Okay. Now if I change the scale to the x value to 3, then you can see it's actually being scaled to the right. Okay. So if I say 0.5, then it's scaled to the half of the size. Okay. So that's scaling. Now, the next one is compositing. So compositing is actually composite, composed from the multiple shapes. So without using compositing, shapes are always drawn on the top of the other. So compositing allows new shapes to be drawn behind existing. So these are the things you can do. So, instead of actually over shadowing it, you can actually have a new shape be drawn behind the existing shape, mask of certain areas, clear sections from the canvas. So, basically you can do a lot of interesting stuff by using compositing. And in order to specify a particular compositing type, you can specify your context object, global composite operation, and then you're going to actually specify that compositing type. Okay, so these are the compositing type. So source over, source in. Yeah, so these are kind of matching. Source over, and this is the default. So the next one, it will override the previous one. This is the destination over. Source in, destination in, source out, destination out, source atop and destination atop, lighter and darker. So you can see, you can actually have a very interesting composite the operations. Okay, clipping is basically doing a clipping. Okay, so nothing really fancy. So let's do compositing it. So here we're gonna just run this one. We actually see all these different examples. So if you take a look at the code, basically all we do is we have a composite types array, and then we have two different we have the circle and rectangle, and then we are basically setting the composite type, source over the first, and source in next, and source out, and things like that, and you just kind of go through it. Okay, so we draw rectangle, set the composite property, and then we draw a circle. Okay, all right, so pretty straightforward. Okay, so the next is basic animation. So the reason we call basic is that the canvas is not really designed to perform animation, but it's all it's actually possible to do animation. Okay, so that's the reason we call animation. So limitation of canvas-based animation, since we are using script control canvas element, it's also very easy to make interactive animations. Okay. However, canvas element was never designed to be used in this way, unlike Flash. So there are some limitations. So the biggest limitation is that, in order to actually provide some kind of animation, you have to actually redraw completely. Okay, so basically you draw something and then we remove everything and then you actually redraw something else in the different location. So it's not the most effective way of actually performing animation, but it's still possible. So if we need to move it, we have to redraw it and everything that was drawn before it. And it could be taking a long time to redraw a complex frame. Okay. And the performance depends highly on the speed of the computer it's running on. Okay, so if you actually have a very complex shapes, then redrawing that one every time you actually kind of have the animated the shape, it could be it could actually it could be slow. Okay. All right, so the steps is that basically you clear the canvas. So you start from the scratch, then you save the canvas state. Okay, and then you draw animated shape and then we draw canvas state. So by actually kind of doing this one over and over, you are basically having some kind of animated kind of aspect of the canvas. Controlling animation, basically we need a way to execute our drawing functions over a period of time. So you can do either of this, set interval or set timeout. Okay, so every 500 milliseconds, it will actually draw things. All right, so let's do animation. Okay, so this is the case, the clock. So it's basically showing the clock animation. Okay. So if you take a look at the code, we basically we basically call inside the init method. Init method gets called when the this page is loaded. Okay. And inside init method, we basically call the clock method, and then we call the set interval to 1,000 milliseconds. So every second, this clock will be called, and basically this clock method will actually redraw everything. Okay, so it basically the rewrite the hours and rewrite the minutes and rewrite the seconds. Okay, all right. So that's basically what's happening. Next one is the landscape. So what it does is that every, let's say interval, basically it computes how much space is actually moving. It actually moves things, and then it will actually move the space out of the canvas here. Okay, so that's basically what it does. Okay, so this is on load, and this is again setting the refresh rate. Okay, so basically the speed is here. Yes, so 30. Is every 30 milliseconds, it will actually call draw. Okay, so in this case, basically it withdraw the rectangle, and then it actually the draw image in that rectangle. And basically what it does is that it actually compute the canvas size. You move the picture to the right, and we actually compute, how much time, how much space, how much actually, piece, rectangle of the picture is actually moved. Then it will actually move to the left. Okay, so we can certainly actually change the speed. Let's try that speed. Okay, so let's run this one. So this is what you see. Okay. And I'm gonna just use this one, and let's run this one a lot faster. So I'm gonna change this one to 10. Save it, and it runs a lot faster. Okay. Now it changes to the 30 millisecond space. All right. Oops. The last one is third-party libraries. Actually, I'm going to just use. Even though Canvas is a brand new feature in HTML5, let's actually build very interesting graphics. The APIs are still considered rather low-level APIs. So obviously we expect the communities or vendors to come up with JavaScript libraries that actually take advantage of Canvas APIs underneath, but providing the high-level abstractions, meaning high-level APIs for writing, for example, the interesting graphics, like a chart. Okay, so I actually have 4 open source. These are all open source, the graphics package that are built on the top of Canvas. Okay, so let's go here, and this is the egel.js, and you can see some demos, and you can see view demos. Yeah, and then so it's actually basically so this one is basically you can do interesting stuff here. Yeah. What is this? Cache vendor. Oh, it's a performance thing. Okay. And so here, basically different blurring, different RGB value, and contrast, whatever. Okay. And you can certainly take a look at the code. Okay. So you can just view page code, and it does have, the not indented. So it might be, you might actually copy this one and then use some kind of indentation to see the code. Okay, so that's egel.js, and next one is chart.js. Okay, so I'm gonna just go to chart.js, and it does have multiple, the various types of the line chart, bar chart, and radar chart, and pie chart, and polar area chart, and donut chart. Okay, so it's very easy to use this chart.js. So where is my chart.js? Oh, okay. So actually, I'm actually looking at this. So I already downloaded the chart.js as part of the hands-on lab. Okay. So you can actually go to chart.js, and let's take a look at donut HTML. Okay. So it's very simple. Basically what is the donut? Yeah, here we go. Okay. So this is the data. Okay, and then of course you have to have this the chart.js, okay, included in your the page, okay, and then it does have a canvas element here, and then basically you are creating some kind of test data, and then all you have to do is basically call chart the object, passing your canvas object context, and then you call the donut the method of your chart object, passing donut data. And that's what you get. Okay. All right. And if I go to another one, pi. Okay. So if I draw this, pi. So very simple to use. Okay, so that's chart. And fabric.js is also another one. Okay. It does also actually have the SVG to canvas and canvas to SVG parsers. Okay, so here you can check out the demos, and you can certainly clipping, and you can certainly see the code. Okay, and what it is, 1,000 particles. Let's see, patterns. All right, so these are all using HTML5 Canvas underneath, okay, but providing high-level APIs, okay. And the last one is kinetics. So here I go to kinetics, and show you. Oh, I think I actually downloaded kinetics as well. Why didn't? Okay. Let's see. Yeah, I think you go to tutorials. I thought actually I saw the demos. Yeah, so these are examples. You can certainly take a look at the source code. Okay, here. Okay. All right. So that's pretty much what I have. Okay, so let me make sure